Hello, and welcome to the SQL for Data Science course. My name is Sadie St. Lawrence, and I'm your instructor and guide for this course. I'm a data scientist for VSP Global, where I build data stories, predictive models, and work with machine learning algorithms to help the organization improve their services, identify new markets, and a whole host of other things. In addition to working at VSP, I'm the Executive Director of Women in Data, where we focus on providing economic opportunities for women in data and fostering global data literacy. With Women in Data, I've led multiple training sessions in data science, which I love because teaching is where my real passion lies. For me, an understanding of SQL is so fundamental to any successful data scientist, so I'm excited to help you learn all about it. If you're taking this course, you might not be too surprised by the fact that data is everywhere. Well, here in the 21st century, data is being collected all the time to help organizations optimize their work. And whether we're aware of it or not, data is being collected and being stored on all of us. Everything from what you buy at the store, to what movies you watch, music you listen to, books you read, your fashion choices, how you use your smartphones, searches you make on the internet, your health, what vehicle you drive, what advertisements convince you to make a purchase, and I could go on and on. Outside the business world, of course, data is collected for important climate change research, healthcare, and medical analysis purposes, and trying to solve the universe's greatest mysteries. Data is even being collected on you right now, as you're participating in this course in order to help Coursera figure out how to improve everyone's online learning experiences. So in the 21st century, data is king. Everyone's collecting it all the time. And I really feel it's those people who can use and interact with data, those use it to critically think and provide insight out of it to make better decisions, those are going to be the people who shape the very world we live in. These people are data scientists, and I think data science is one of the most rewarding and interesting fields you can get into right now. But to be a good data scientist, you need to know how to retrieve and work with data. And to do that, you need to be very well versed in SQL, the standard language for communicating with databases. The purpose of this course is to give you a primer in the fundamentals of SQL and working with data so that you can begin analyzing it for data science purposes, asking the right questions, and coming up with good answers to deliver valuable insights for your organization. In this course, we cover a lot of ground. In fact, I really start at the beginning. While having a little bit of knowledge of SQL will already help you out, I'm not going to assume you know anything about SQL. I'm really going to start from square one here. You'll learn all about SQL syntax, common statements, concepts, and terminology. We'll discuss how to write both simple and complex queries to help you select data from tables and work with it. And we'll talk about working with different types of data like strings and numbers. We'll also discuss methods for you to filter down and pair your results. And we'll talk about creating new tables altogether and moving data into them. I'll introduce to you common operators like where, like, order by, between. And we'll talk about how to combine data using various types of joins. We'll even go over how to use case statements and spend a little time on concepts like data governance and profiling. Along the way, you'll participate in discussions about data and work on real-world programming assignments in order for you to practice your newly learned skills. No matter your level of experience, I promise you that by the time you finish this course, you'll be able to interpret the structure, meaning, and relationships in source data and use SQL as a professional to shape your data for targeted analysis purposes. As you can probably tell, I'm really excited about this course, and I hope you are too. All right, so let's go ahead and dive in. Welcome to our first module. I'm going to assume that most of you are brand new to SQL. So new, frankly, that you might not even know what SQL really is other than a computer language used to talk to databases. So in this module, we're going to start there and both define SQL and discuss how SQL differs from other computer languages. I'll also explain the various ways that SQL is used within a database. From there, we'll compare and contrast the roles of a database administrator and a data scientist, and explain the differences between one-to-one, one-to-many, and many-to-many relationships with the database. Once we've covered that, we'll learn our first statement, select, talk about some of the basic syntax rules, and go over the importance of commenting in your code so that you can start working on and writing some simple queries right away. I know you're eager to begin, and so am I. So let's get started. Welcome. In this lesson, we're going to go over what SQL is, but more particularly, how data scientists use SQL. That's really what this class is about. I don't only want you to understand how to use SQL, but I want you to understand how it's used in data science and how that may be different from how other people are using SQL. Specifically, after this lesson, you should be able to define SQL, discuss how SQL differs from many other computer languages, explain the three primary ways SQL is used with the database, and compare and contrast the roles of a database administrator and a data scientist, along with discussing the importance of knowing what SQL syntax you're using in a given database. So let's begin with the acronym SQL and what it stands for. This is Structured Query Language. This is the standard language for many relational database management systems and data manipulation. SQL is used often to query, insert, update, and modify data. At a basic level, SQL is a method for communicating between you and the database. One of the great things about SQL, though, is that it's made up of statements which are descriptive words. In other words, many of the commands used in SQL are fairly easy to interpret, as compared to many other computer languages. This makes SQL, as a language, really easy to understand and learn. However, it's important to understand that SQL is a non-procedural language. That means you won't be able to write complete applications with it. But what you can do is interact and communicate with data. This makes it relatively simple, but also very powerful language. When you think about SQL, all you need to think about is data. SQL is all about data. SQL is really used for three things. It's used to read and retrieve data, so data is often stored in a database. And you want to retrieve it or read it. And you can use SQL as a means to be a translator for that. SQL is also used as a way to write data in a database. So if you need to write data in a table or insert new data, you can use SQL as a means to do this. And finally, it's used to update and insert new data. As you can see, SQL has a really simple design, right? It's very contained in what it's able to do, which is read, write, and update data. Because of this, you will find there are a lot of people who are able to use this language. If we look at this graph, what we see is the SQL language ranked by the number of programming jobs. This is from Indeed.com in 2016. It ranks SQL as the #1 language. There's a lot of jobs out there that require the use of SQL, and it's not just for data science. It's important to understand how others use SQL and how other people other than data scientists and programmers might be using it. There are many, many people who might use SQL in their jobs. This includes everything from back-end developers, QA engineers, data architects, system engineers, obviously data scientists, and even data analysts. But the ones I want to talk about a little bit more are the DBAs or database administrators and how they compare to data scientists. A DBA is responsible for managing the entire database and guarding it. A data scientist, on the other hand, is typically a user of that database. The DBA will be responsible for giving permissions to people and determining who has access to what data. They're oftentimes responsible for managing the tables and creating them. We're going to go over how to create your own tables and insert data into them in a later video. However, this is something you'll likely have to get the rights to, and often from a DBA. The ways the two positions, DBA and data scientists, are similar is that they both use SQL to understand the data, to query it and retrieve it. They both write very complex queries, but the main difference is that the data scientist is really the end user, whereas the DBA is the one who administers it, governs it, and manages the database as a whole. Data scientists have to be able to retrieve data. We know we can't do anything until we actually have the data to work with, right? We need a way to go and get that data. SQL is really fundamental in data science because you really can't start building any models or doing any predictions until you have the data. SQL is the means to go into a database and get this data. Data scientists might also use this to create their own table or test environment. Let's say you've built a model and you want to deploy that, and you want to add it back into the table. You may need to create your own table or test environment to add that into. One thing that is not unique with data scientists or other people using SQL is that you oftentimes are combining multiple tables together, and a lot of times this leads to a bit more complex queries to be written for analysis. Data scientists, though the number one way that they're using SQL is really to be able to retrieve their data for analysis, they might do a little of the analysis using SQL. However, the main thing they're using SQL for is for data retrieval. The last thing I want to point out is that just because you're learning SQL in the class, the syntax of what you're writing may change a little bit based on the relational database management system you're using. Again, you can think of SQL as the interpreter between you and the database. How you write some of the syntax for SQL is going to depend on the relational database management system you're interacting with. Extending our analogy, you can think of this as the accent, or maybe as the dialect. SQL is able to translate it for you, but sometimes you have to tweak it a little bit based on the database management system you're using. Here I've listed just some of the popular ones: SQL Server, PostgreSQL, MySQL. In this class, we'll be using SQLite, so I'll be teaching you the syntax based on that. I want to point out this, though, because I think it's important to understand that if there's something that doesn't work correctly when you copy data from this class into another application you're using at work, definitely check the type of relational database management system you're using and see if that makes a difference. I'll talk about this some more in an upcoming video, including some of the ways to figure out what those differences might be. Okay, that's it for this lesson, and you should be able to tell others what SQL stands for and discuss how it differs from other common computer languages. You should also be able to explain a few ways that SQL is used in a database, understand the roles of a database administrator and a data scientist, and be able to explain the importance of knowing the SQL syntax you're using within a database management system. Over the next several video lessons, we're going to spend some time talking about data models and ER diagrams. The reason why this is important is because while you may be able to learn SQL, you won't be as effective in writing your queries without an understanding of the structure of the data that you're querying against. After this particular video, you should be able to explain the importance of thinking through the design of a query that solves a particular problem before writing a single line of code, explain the importance of understanding how the data in a database relates to one another, and describe what a database is at its core. When I first started to learn SQL, I took a 3-day training class, and this is what I'd call a point-and-click training class. It's a very basic class where you just follow the exercise in a book and duplicate what it was doing. It taught me how to write in some different select statements to retrieve some data, and I was able to perform a few operations. However, when I went off and encountered different real-world problems, I really had a hard time applying what I learned to most situations. It wasn't until I took another class that was a bit more theory-based that I began to understand data models, ER diagrams, and how those interact with SQL. I learned how to apply SQL to that, and that's when my queries improved by leaps and bounds. I was then really able to apply what I was writing and coding to pretty much any situation. This lesson is so fundamental into everything you're going to do after this. I really hope you can take the time to do your own research and get interested in this because it's going to help you understand queries and SQL in a far greater way than just purely studying SQL language itself. I think the most important thing you can learn from this class is a concept I call think before you do. What I mean by this is it's easy when you're doing work or we're trying to produce a result or solve a problem to just go in and start doing. By that I mean you go in and start to write code, or maybe start to write some type of email, or you're starting to form a model and recreating your data. What I want you to do before you start to do that, so before you start to go in and start to write a query, is I want you to think about what you're doing. I want you to think about what is the problem you're trying to solve. And you need to determine what is the data you need to get. And figure out how does the data relate to each other? How does it interact? You'll probably also need to think about what are some of the problems that you may want to solve with this data and need to be aware of. And what are the types of joins or business processes in the data modeling? This will really help you because not only will you get more accurate results, which is fantastic and what we want and need, but it's going to actually speed up the time it takes you to work and get things done. I think we as individuals, and I know I definitely fall into this pattern a lot, tend to think that we're getting things done by going out and writing things and acting, whether it's queries or some type of document. But if you actually take the time to think about why you're doing what you're doing before you do it, it will actually take less time to write your queries. If you really spend some time understanding how the data relates to each other, how you're going to join these data together, what columns you need, why you need it, this will then in turn speed up the process for writing your queries. The SQL language just falls into place then. It becomes very simple when you have a good understanding of this. If you start to think about what you're doing before you do it, you should hopefully also have less rework. And you're going to get more accurate results, and you're going to get them the first time. In thinking before you do, it's important to both understand what you're thinking about and what you're doing. When you're writing queries, I've talked a little bit about how this is a translation system for you to communicate with the database. It's important to understand what a database is. A database is really a container that is usually a file or set of files and is used to organize and store all of the data. If you think of this in real-world terms, it'd be like a filing system that has many cabinets along a wall. Within that system, within a database, we have tables. These tables are a structured list of data elements or a specific data type. Going back to our analogy, you can think of this as maybe one of the cabinets within a whole wall of cabinets. Then if we dive further into the cabinet, into a table, what we find is we have columns and rows, which of course is what makes up a table. A table is made up of a series of individual columns, and then a row in a table is a record. Through tables, rows, and columns, ultimately throughout the database, we have a mechanism to store and retrieve data, and through data modeling, a way to organize and join data together for the purposes of data analysis, and we'll discuss that later on in our course. Welcome back. In this video, we're going to continue where we left off in our last video by talking a little bit about the evolution of data modeling and consequently SQL database systems themselves. It's actually a pretty interesting history that really begins in the 1960s as computers were really coming into their own as a business and research tool. After this particular lesson, you should be able to describe what data modeling is, define a relational database system, and discuss the advent of the relational databases in SQL. Data modeling is what we use to organize information for multiple tables and how they relate to each other together. This helps tremendously in providing structure to the information in the system. Usually a data model represents a business process, and it can also help you understand a business process. A lot of times you'll work with a business person in understanding the data and how it fits together. But at the same time, that business person will learn a lot from the data modeler to better understand how their business actually works together by seeing the data and how it interacts with each other. The thing to remember about data models is that it should always represent a real-world problem as closely as possible. There are a couple different types of models, and there has been an evolution of data models. When I talk about data models here, it's important to realize the difference between a model for prediction, which data scientists often build, versus a data model, which is really a way that the tables are represented and organized in a database. The evolution of data models has gone on since the 1960s. There's been hierarchical, network, relational entity, relational semantic, and NoSQL. I'm not going to go into great detail into all of these different types of data models. If this is interesting to you, I definitely recommend you do your own research. It's widely available on the internet, and it will only help you in other aspects of working with data. I'm just going to briefly talk a little bit about the relational and NoSQL. The reason I'm talking about the relational is this is what we're going to work with a lot when writing SQL queries. The benefits of a relational model is that they really simplify the connections between the data, and what it does is easily allow you to write queries against it, retrieve it, update, and write data to it. NoSQL came onto the scene around 2009. It was really part of the big data movement that you may have heard something about. I think it's important to understand that NoSQL is out there, especially as you're learning the SQL course. I think it's also important to realize the differences between the other data models and NoSQL. Just to touch on SQL in the big data world, NoSQL is really a mechanism for storage and retrieval where it's not modeled in a tabular relational format. NoSQL was really popular when big data and unstructured data first came out because you left it unstructured. But it's now started to soften a little bit and more commonly referred to as not only SQL. This will be one of the discussion items in this module. Something I want you to think about and research a little bit more is, does SQL really have a role still in the big data world as new things start to come out like NoSQL and unstructured data? Okay, that wraps it up for this lesson. You should have a good sense of what data modeling is and a basic understanding of a relational database. In the next lesson, we'll discuss how relational and transactional databases differ. Okay, now let's wrap up our discussion about data models by getting back to talking about the type of data models we'll be working with in this class. After this video, you should be able to define and describe both relational and transactional database models, define entities, attributes, and a relationship, describe and explain the differences between one-to-one, one-to-many, and many-to-many relationships, describe the use of a primary key in a database, and explain how ER diagram is used to document and illustrate relationships. I want to kick off this video by talking a little bit about relational versus transactional database models. A relational model is a database design that shows the relationships between the different tables, and this is really used to optimize querying data, making it easy and intuitive to access the data. Transactional, on the other hand, you can think of as a more operational database. If you are in healthcare, for example, you may have a transactional database that is used to store all of the claims information, and then this information may not be stored in a great way for querying and using it for analysis. In fact, you may need to take and extract that transactional information from the database and move it into a relational model. Most of what we'll be working with in this class is the relational model. The building blocks for this relational model are really three simple things. We have entities, which are a person, place, thing, or event. These are very distinguishable. They are unique, they are distinct. For example, I could be an entity, Sadie St. Lawrence, and then we have attributes, which are characteristics of this entity. As an entity, it would be myself, and then an attribute about me would be that I am female. Then the third building block of the model is the relationship. This describes the association among different entities. There are a few types of relationships in a database, and the ones I want to cover are the three shown here: one-to-many, many-to-many, and one-to-one. If you think of a one-to-many relationship, this could be one customer that has many invoices. When you think of a many-to-many relationship, this could be an example of many students to many classes. You may have one student who belongs to lots of different classes, or you may have a class who has many different students. Then if you think of a one-to-one relationship, this is a manager to a store. Let's say you have a sporting goods store, and each of those stores has only one manager. That would be one example of a one-to-one relationship. To understand these relationships between the tables a lot better, what's often used to depict this are ER diagrams. An ER model then is composed of the entity types and the specific relationships that can exist between these entities. These are usually displayed in a visual format and represents the relationship between the tables. It often helps you to understand and represent a business process, and it will show the links between these tables. The links are really important because in a later lesson, we're going to learn how to join these tables together and combine the data. Being able to look at this diagram and see how they relate to each other is really important. What we will use to join these tables together are two things. We can use the primary keys or foreign keys. The primary key is a column or set of columns whose values uniquely identify every row in a table. Then this allows us to take those unique identities and then join it to another table. Foreign keys are similar, but in regard that one or more columns can be used together to identify a single row in the table. When we're looking at ER diagrams, which again is one of the ways you will start to think before you do, you'll look at maybe an ER diagram and understand what data elements you are trying to join together and how do you need to get them. But one of the things you need to understand is how to read this. We talked a little bit about relationships and the different relationships between a table. And then there was a different type of notation that explains the relationships. We have the Chen notation, and there's the crow's foot notation, and then there's the UML class diagram notation. The Chen notation uses 1 to M for a one-to-many relationship, and M and N for a many-to-many relationship, and a 1-to-1 for a one-to-one relationship. In crow's foot notation, we have the train tracks, which represent 1, and then the crow's foot, which represents many. And finally, with UML, we have a 1.1, which represents the concept of 1, and 1 point asterisk, which represents the concept of many. Definitely take notes of these. You'll be looking at ER diagrams quite frequently, and you'll need to understand these notations when reading ER diagrams so you can understand how you're going to write your query and join the table together, or even to find out what's listed in the table. This is really part of that thinking before you start doing concept I was talking about earlier. Having a good understanding of why the data is structured in a particular way and how to read the ER diagrams will be very helpful to you in writing your queries and ensuring you get accurate results. In this video lesson, we're going to go through the backbone of retrieving data with the select statement. As we talked about previously, the majority of what data scientists are doing with SQL is retrieving data. To be able to do that and get you started, the first statement you're going to use is called the select statement. After this lesson, you'll be able to write a basic select statement, tell a database what table you want your data from, select either all or particular columns from a table in a query, and limit the amount of data that is returned in a query. With a select statement, you're going to specify two pieces of information: what you want to select and where you want it from. Let's look at the concept using an example. So in this example, I'm going to select product name, that's the column from the table I want, and then I'm going to say where I want to get it from. So I want to get it from products. The output of this is then going to look like the column listed below, which it has the column product name and then all of the list of products. We have shampoo, toothpaste, deodorant, and toothbrush. If you want to retrieve more than a single column from a table, then what you need to do is add the names of the individual columns together. But add a comma after you add the column name. So in this example, we'll still select from the products table, but we'll also select the product name, the product ID, and the product price. You can see below that I've written this same query in two different ways. I like to usually write it the second way because it helps me make sure I don't forget any commas after I wrote a column name that I'm selecting. So each statement is the same. One to me is just a little bit easier to read, so that's why I write it the second way. But both statements will produce the same results. Now let's say you have a table that has 20 columns, and you want all of the columns in the table. Instead of having to write out each individual column, which would take quite a while, there is a wildcard that you can use, which is the asterisk. So you can put select star and then from products, and this is going to go ahead and grab everything from the products table, each individual column, and put it into your output. So that's the fundamentals of using select. Anytime you're retrieving data, you are going to have a select statement. Because you're retrieving data, you need to say something as, hey, go get me something. This is what select is for. And the from that accompanies it will always go hand in hand, because if you're selecting something, you need to tell SQL in the database where to get it from. A lot of times, though, we may want to pull the whole table to get a view of it, to understand what data is in there. So we may do a select star. But if there is something like 5 million records in it, and we may just really want to get a sample of that. So just to view some of the data in the table, we may need to limit our results. To do this, we can select the columns we want from the table we want. Then, after the from statement, we're just going to put a statement that says limit. And you can put the number. For this, I'm going to limit it to 5. So I just want to see the first 5 records. Here, though, I've also listed the differences in how the syntax of this is written for different relational database management systems. I'm not going to spell it out individually for every statement and how it differs from the different systems. But this, as I've mentioned before, I want you to be aware of that there are differences in syntax. In the meantime, we're using SQLite. If you understand it's limit 5, and then you switch over to a DB2 system, that's still something you can easily Google in terms of saying, hey, I'm using a DB2 system and I want to be able to limit my results. What's the syntax to be able to do that? Just know that here, in this example, we're going to use a limit 5 because we're working with SQLite. But you can see that for Oracle, you can use where the number of row number is greater than or equal to a number. Then for DB2, you can use fetch the first 5 rows. Okay, so that's it for this one. So this video's really gone over the backbone of retrieving data. I showed you a couple examples of how to select an individual column, multiple columns, a whole table, and then also how you can limit your results. These are really the key things you need to know in order to understand writing basic queries. So we've spent some time discussing the basics of databases and how to retrieve data from tables. But there's something else we can do with SQL too, and that's actually create new tables and store data within them. In this lesson, you'll learn how to be able to discuss situations where it's beneficial to create new tables within an existing database, write data in a new table, and define whether columns can accept null values or not. The ability to create tables and store data in them is really beneficial as a data scientist because you're always making models and building predictions. You may want to take those predictions that you create and write them back to a database. This ensures that someone else could then pick up those predictions and use them in a dashboard they're creating, or maybe you want to create a dashboard or visualize it with another tool that can be hooked up and used with that database. It's also helpful if you're extracting data off the web or scraping it from somewhere and you want to store this data in a database with the rest of your information. That way you can then join it back together. As we previously discussed, the data scientist isn't usually the one in charge of managing the entire database. That's usually left to the DBA or some type of administrator. However, they may have capabilities to be able to write and create their own tables. So it's important to have a basic understanding of how this works. In order to do this, there is a statement that we use called create table. So in this example, I want to create a table that is about the different shoes I have on my shoe rack. Maybe I want to start to look at things like how long I've had the shoe, the different brands, how much I paid for them, or look for shoes that I have that are similar or maybe different colors. I may even want to look and see if I'm missing any shoes from my wardrobe. For this statement, you're going to need a table name. Then you also need the name and definition of the columns. In this, you'll also need to define the data type. To do this, we're going to write the statement, create table. We'll put the name of the table, and then in brackets, we will separate out the list of columns that we're going to name this table. In this example, I have the columns as shoe ID, the brand, the shoe type, the color, the price, and the description. After I list the column, I'm going to define the data type. For this, I want this to be a character with 10. Then I'm defining some specifications around that column. The shoe ID is going to be my primary key in this example. You can see by the other columns, I've also defined the data type, how many characters or decimals I will allow to be inserted into this column. Then I also put whether or not I'm allowing no values in this. If I'm not specifying, then it's assuming that no values are accepted. In this example, it's a pretty simple example because the syntax for creating these tables varies greatly by relational database management system that you're using. This will give you the basic structure to create your table. However, it's important to look at the specifications of your relational database management system you're using so that you can get the correct syntax for this. An important thing to note when creating these tables is defining whether a column can contain a null value or is a primary key. Every column you have in a table can either accept null values or not, and you need to define this capability. As shown in this example, I've created a table with several columns, some of which cannot accept null values. Those are not null lines. And the one column that can accept null value, the one line that has null in it. It's important to not confuse null values with empty strings. Null values really are the absence of everything, whereas empty strings, there's actually a value there. It might be spaces or something like that. Another thing that's important to remember is anything that you're defining as a primary key cannot accept null values. So the one line listed here as the primary key wouldn't be able to accept null values for this example. As previously defined in the example, I said that shoe ID was the primary key. Therefore, this can never have an empty value or not any value. The other thing that's important to remember is that if you indicate that a column cannot be null, then you are going to get an error if you do not enter a value into that column when you're inserting data into it. This is just a check to make sure that in the columns that you've determined are non-nulls, values will always be present. Otherwise, you'll get an error returned. In order to get the data into the table, after you've defined the table, the columns, and the data types you want to add into it, there are really two ways to do this. The first way is to insert with the insert statement. You can say insert into shoes. So I'm saying I want to put this data into the shoes table. I want to put the values in after that. So in this, I have put the values into a single parentheses. I've listed them out in order. Now this works fine. However, I wouldn't recommend using this first example. How this first example is going to work is that it's going to take the first value indicated and put it in the first column. The second value will go into the second column, and the third value into the third column, and so on and so forth. And it will put them in order. As I said before, it works, however, it's not recommended. You have no guarantee of what data is going into which column. So it's a lot better to be a little bit more specific about this. For this, what you want to do is you want to use the same statement, insert into shoes. Before I put the values, I'm going to list the columns that I want it to insert into. Here I'm listing it in the same order: shoe ID, brand, type, color, price, and description. However, this time, after that, I'm also indicating the values that I want to go in that same order. This can be really beneficial if you want to insert just a few values into a column. So for this example, I could remove the first three, so I could remove the type, brand, and ID. I would just remove those by crossing those out. Then it also removed the first three values here. Now I'm guaranteed that the values pink, $6.95, and then null are going to go into color, price, and description. I would recommend using this method. It's a little bit safer because you have more control. You know exactly where the data is going and into which column. Okay, so let's stop there for now. In this video, you learned all about how to create tables using SQL. We discussed situations where that's a useful thing to do. We talked about the syntax for creating a new table and went over how to store data in it. There's another thing you can do with tables, and that is to create a temporary table. We'll go over this in our next lesson. So in our last lesson, we went over how to create tables in a database using SQL. Another option we have is to create a copy essentially of another table, or pull a subset from another table. We can create a whole table from this, or we can create what is called a temporary table. And that's what we're going to go over in this video. After this lesson, you should be able to create temporary tables, describe the limitations of temporary tables, and discuss some strategies for researching syntax for particular database management systems. Okay, first of all, the most important thing to know about these temporary tables is that these will be deleted when the current client session is terminated. That's why they're called temporary tables. However, these are really good to use because they're a lot faster than creating a real table. So if you have complex queries and you want to simplify it a bit by creating a subset and then joining to that subset and deriving a new calculation from that, then temporary tables are a great option. For this, we use the statement create temporary table. Then we put the name of the temporary table we want to create. Then this I'm pulling in as a subset from another table. I'm going to say add. Then in my brackets, I'm going to put my select statement of where I want to get this from. In this case, I'm pulling a subset of data from my shoes table. Right here, I'm just creating a temporary table that is the shoe type sandals. Now I create an individual table, which is just going to have those shoes that are sandals. As mentioned before, the way you create tables, update them, and insert them is heavily dependent on the relational database management system you're using. In this class, we're using SQLite. However, you do not have write privileges to this. You won't be able to write any data to this, but I think it's important to realize you need to look up this information on your own based on the company you're at and the type of relational database management system they're using at that time. This graph depicts the flow of what you need in order to create a temporary table. So as you can see, there's a little bit more detail here. What I would highly recommend is looking up the relational database management system you're using and then finding the syntax detail for how to create the table with the relational database management system you're using. It's really great if you can become your own researcher and troubleshooter when working with SQL. The key is to really never stop learning how to optimize your queries or how to work with relational database management systems. For this, I really want to teach you the core basics and the fundamentals so that you would know how to think logically about these problems and work through them. At the end of the day, you're going to be your own best teacher. For this, I recommend Googling or using Stack Overflow, which is a site dedicated to asking and answering coding questions. You'll be able to get a lot of great information there. As this language is dependent on the database management system you're using, make sure that when you're typing or researching these items, that you're typing the name of the database management system in as well. This will be helpful because you may find the solution to your problem implemented. There may be different syntax based on the relational database management system you're using. I'd like to challenge you to research some of these things on your own based on the relational database management system you're using at work. Go ahead and look up the statements for updating tables and deleting tables and see if there is anything related to the database management system you're using. So to wrap up, in this lesson we learned how to create temporary tables and write data to them. We also covered some limitations of using temporary tables, chiefly that they are temporary, and we talked about some strategies to research different syntaxes for SQL statements. I really encourage you to do some research in this regard. You will always learn a lot when you go out and explore these topics on your own. Hi there. So as you can probably guess, SQL code can get pretty messy. Well, we've only focused on simple queries so far. Most queries are multiple and often many lines long. Sometimes it can be difficult for you or someone else looking at your code to understand what's going on in the design of the query. So in this video, we're going to talk about adding comments to our SQL code in order to help shed light on what we're trying to do with our code. Adding comments is important not only because it makes your queries easy to understand, both for you and for others, it's also going to help with troubleshooting your code and making your code easier to share overall. After this lesson, you should be able to discuss the importance of writing comments as a part of your code, describe several comment syntaxes that can be used in SQL, and of course, actually write comments in your code. Let's begin. If you've written in any other programming language, you know that comments are helpful when you've written some code and you've gone away from it for a while and when you come back to work on it again. You want to understand what you were doing. The same thing applies here. You may write some code to retrieve some data, go back, work on it for a while, and then decide to come back and modify your query for the data you want to retrieve. Just adding a few helpful comments here and there is just going to make it far easier to understand what you were doing and why you were doing it. But you can also use the comments to mute the expression of some code, frequently referred to as commenting out code. This technique helps you troubleshoot some of the issues you have with your query a little bit better. You can effectively get rid of parts of your query without actually getting rid of the statements themselves, and then bring them back in one by one to see where your query goes awry. So there are two ways to add comments. One is by adding single line comments, and the other is by adding a section of comments. In this, I'm selecting shoe ID, brand ID, my shoe name from shoes, and I just want to comment out the brand ID. I don't need it here. So I'm going to add 2 dashes, and it's just going to remove that whole line. When I run this code block, that's what's going to happen is I'm just going to get the return for the shoe ID and the shoe name. In the next example that I've done is comment out a section of the code. As you can see, to do this, I've used a combination of a backslash and an asterisk. What this is effectively saying is don't run anything between the 2 backslashes and the asterisk. This you can use for a large portion of queries, and it becomes really helpful when you want to just narrow down the one individual line that you want to run. Use these before your select statement to denote what you're doing. Also use these to cross out portions of what you're doing and to troubleshoot different aspects of your code. At the same time, as helpful as comments are, you can definitely have comments go wrong. So it's important to understand how adding comments in the right way can be helpful to you in understanding your code, but sometimes comments can be overly done and can definitely confuse you. I think it's good to realize keeping your code organized, keeping it in a really standard format is just going to make it a lot easier to read. And then add comments where it doesn't follow the normal flow or syntax, or just little points that you may want to read or note for later. Here are a couple examples where there are too many comments and comments gone wrong. And this is another example where the code is just much more simple, easy to read, and you can definitely follow what's happening by looking at it and following the logical pattern through reading each one. But you can also, at the same time, see where comments are placed really elegantly at just the right place to help you understand what's going on. Now, one last point that isn't really part of comments discussion, but something you may find helpful in general, is using a source code or text editor. A lot of times, the relational database management system you're using will have somewhere to input your queries, but sometimes just writing them outside in a source code editor so that you can modify them and save them is really helpful. One I use all the time and always recommend is Notepad++. It might be something you're interested in downloading and using to start writing your queries. It can also help a lot with automatically color highlighting your different statements and can help you with some of the indentation to make sure you're writing your code and it's nice and clean. Okay, that wraps it up for our discussion on comments. Now you should be able to start writing comments in your SQL code to help yourself and others understand your design intentions. I heartily recommend you get in the habit of commenting in all your coding now, as you're just beginning with SQL. So it's something that becomes second nature to you as you work on more complex queries going forward. All right, we went over a ton of material in the first module. I just want to take a quick moment to recap before we move on. We first began by defining SQL. You should know now that SQL stands for Structured Query Language, and that it's a standard language used to communicate with relational database management systems. Speaking of relational database management systems, you should also know the difference between a transactional and a relational database. We also began to go over the very important concept of primary keys, foreign keys, and table relationships. Pin that because we're going to revisit these concepts in a lot more detail later in the course when we start talking about joins. We also discussed some basic SQL syntax, and you should now be able to write basic query statements using select and from. Finally, we are wrapped up by going over how to write comments in your code, which are essential to include so that both you and your colleagues can follow what you're doing and trying to do in your code. It's a really good habit to get into as you're starting out, so be sure to keep practicing that aspect as you begin to write your first query statements with SQL. In our next module, we're going to go over the methods for sorting, filtering, and paring down your data results. As you've probably seen by now, some data sets contain millions of records, and it would be crazy to try and look at all of them. So this is an important skill to have. I look forward to seeing you there.
Thank you for watching our video. We hope you found it helpful. If you enjoyed this video, please hit the like button below and subscribe to our channel for more videos like this. If you know someone who could benefit from this information, please share it with them. We would love to hear your thoughts on this learning course, so please leave a comment below. Thanks again for watching, and we'll see you in the next video.